Okay, this is the practice problems in our packet for rotation. Okay, 6 problems here. So the first one is a 90 degrees counterclockwise rotation. So the first thing we want to do is graph our original points. So A was 2, 7. B was 6, 5. And C is 4, 1. We want to rotate this 90 degrees counterclockwise. So again, counterclockwise is this way. Okay, for rotating, we have 2 steps. Rotate 90 degrees or 270 degrees, we have 2 steps. We want to switch the coordinates. Okay, and then we want to find the sign. So to find the sign, we have to know where the point is going. So if the point ends up in the first quadrant here, it's going to be positive, positive. If it ends up here, it's going to be negative, positive, negative, negative, and then positive. Okay. So let's look at A. We're going counterclockwise, so we're going this way. 90 degrees is a quarter of the way around. So if we have 4 quadrants, we're only going 1 quadrant over for a 90-degree rotation. So we're going to rotate this 90 degrees. So our first step is to switch the coordinates. So 2, 7 is going to become 7, 2. And then we need to look for the signs. So right now A is in quadrant 1. We're going 90 degrees counterclockwise, so it's going to end up in quadrant 2. And the signs for quadrant 2 are negative, positive. So it's a negative 2 and a positive, negative 7 and a positive 2. Okay. The next one, B is 6, 5. So the first step here is to switch the coordinates, so make it a 5 and a 6. Okay, here's B. B is in quadrant 1. If we're going counterclockwise, 90 degrees, we're going 1 quadrant over. So 90 degrees counterclockwise puts us in quadrant 2. The signs for quadrant 2 are negative, positive, so it's negative 5, negative 6. Okay. C, again, same thing. First step is switch the coordinates, so it's going to be a 1 and a 4. C is also in the first quadrant, so if we go 90 degrees counterclockwise, that's 1 quadrant over. So it's going to be in quadrant 2, which makes it a negative and a positive. Okay, so let's plot our points here. Negative 7, 2. Here's A prime. Negative 5, 6 is B prime. And then negative 1, 4 is C prime. So this gets rotated here, this gets rotated here, and this gets rotated like that. Right, this is getting rotated 90 degrees. This would be 180, and then this would be 270. Okay, so there's our coordinates and our rotation. Okay, 180 degrees is the second one. So 180 degrees rotation is halfway around, so all we're doing is switching the signs. Okay, so let's graph our square. So T 2, 6, P 6, 5. Okay, 5, 1. And 1, 2. Okay, this is supposedly a square. Did you do something wrong? Oh, it's 1, 2. We want to rotate this 180 degrees, so all we do is use our rule for rotating 180 degrees, which is xy goes to negative x, negative y. So it's like 2 90-degree turns. So when we go 90, the coordinates flip to yx, and then when we go 90 again, they switch back to xy. But in this case, you're going to be on the opposite side, so you're going to have the opposite sides for both the x and the y. So let's find our points here. So 2, 6 is going to go to negative 2, negative 6. Okay, 6, 5 is going to go to negative 6, negative 5. Okay, and so on. We get negative 5, negative 1, and negative 1, negative 2. So we can plot those points. P prime is negative 2, negative 6. Negative 6, negative 5 is Q prime. Negative 5, negative 1 is R prime. And then S prime is negative 1, negative 2. So we still maintain the shape, still maintain the square, it's just on the other side, 180 degrees around. Okay, number 3 is a 270-degree rotation. Okay, so we have a trapezoid, JKLM. So let's graph our trapezoid, JKLM. So J is 3, 4. 6, 4 is K. 1, 1 is M. And 8, 1 is L. Okay, so there's our trapezoid. We want to rotate 270 degrees. So 270 degrees would be 3 quadrants away, 3/4 of the way around. Or we could go counterclockwise 90 degrees. So you can think of it as going counterclockwise 90 degrees, or you could go 3 quadrants around. 270 is done exactly the same way as 90 degrees because 270 is 90 degrees going the other way. So the steps here are going to be switch the coordinates and then find which quadrant we're going into. So here, 270 degrees is going to land us in quadrant 4. So all 4 of these points are in quadrant 1, so all 4 are going to end up in quadrant 4. Okay, again, or you can think of rotating it 90 this way. So J is 3, 4, so step 1, switch the signs. Okay, we're going to end up in quadrant 4, so that's a positive x and a negative y. K, first step is switch the signs, so that becomes a 4 and a 6. And again, we're going to end up in quadrant 4, so that's a 4 and a negative 6. L prime, so L is 8, 1, so the first thing we want to do is switch them, so 1, 8. Okay, and again, we're in quadrant 4, so that's going to be a negative 8. 1, 1, we're going to switch. And we're going to have to make it negative because we're in quadrant 4, so positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Okay, so let's graph it out. J prime is 4, negative 3. We have 4, negative 6, which is K prime. We have 1, 8, which is L prime. And then 1, negative 1 is L prime. So we've rotated it down 90 degrees, right? Rotating K 90 degrees. 90 degrees. Oops. 90 degrees. I made a mess of it now, but you get the picture, I hope, right? Okay, the fourth one here is another 270-degree counterclockwise rotation, but we just want to know n. So the one thing we want to do is write down n. So n is negative 1, 4. Okay, we want to do a 270-degree rotation. So 270 degrees is going to put us in quadrant 2, or we could do 90 the other way, which is going to put us in quadrant 2. So the first step here is we want to switch their numbers. So we have 1, 4. That becomes 4 and 1. Then we want to determine what quadrant we're going into. Well, we're going into quadrant 2. So that is negative x and positive y. Okay, 2 more. These are doubles. Zoom out a little. So we can fit it all. So D is negative 6, negative 1. E is negative 3, negative 2. And then negative 5, negative 7 is F. not draw that very well. Okay, so there's our triangle. We want to reflect over the x-axis first and then rotate 180 degrees. So I'm going to put D prime, E prime, F prime, and we'll call these double primes. So reflecting over the x-axis, so we can just reflect it over by counting. D is one above, so D prime one below. I mean, D is one below, so D prime is one above. E is two below, so E prime is two above, and then F is seven below, so F prime is seven above. Okay, so we reflect it up. Okay, to fill in our points though, again, we can just use the rule. So the rule for reflecting over the x-axis was xy goes to x negative y. So here we're just going to switch the points. So negative 6, 1, 3, negative 3, 2, and negative 5, 7. So our next step then is the 180 degree rotation. So 180, we just switch our signs. Sorry. Okay, so this is going to go to negative x, negative y. So we're just going to switch our signs here. So this is going to become 6, negative 1, 3, negative 2, 5, negative 7. So 6, negative 1 is D, double prime. E double prime is 3, negative 2. And then F double prime is 5, negative 7. Oops. Okay, so again, these are all isometries. They're all rigid transformations. We're reflecting over and then rotating 180 degrees. Number 11 here. Okay, let's plot our points. We have a rhombus, so G, H, I, J. So negative 1, negative 3 is G. Oh my God. All right, H is 3, negative 4. I is 4, negative 8. And then 0, negative 7 is J. Oh, jeez. There's a rhombus. All those sides are equal. Okay, you want to translate it first by the rule x plus 4, y plus 10. So we can either plug in, so I'm going to put G again, G prime, H prime, I prime, J prime, and then we'll call these double primes. Okay, so we can either count or plug it in. So I'm going to plug them in. So negative 1 plus 4 is going to give us 3. Negative 3 plus 10 is going to give us 7. 3 plus 4 is 7. Negative 4 plus 10 is 6. Okay, 4 plus 4 is 8. Negative 8 plus 10 is 2. 0 plus 4 is 4. Negative 7 plus 10 is 3. Okay, just to verify the right, well, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 1, 2, 3, 4. 10 up. Yeah, so we're going to go 10 up. So here's going to be J prime, G prime. 7, 6 is H prime. 8, 2 is I prime. And 4, 3 is J prime. So our rhombus is still in check. Okay. Then, so we're good here, and then we want to rotate 90 degrees. So again, all these points, we're counterclockwise, all these points are in quadrant 1. They're going to all end up in quadrant 2, which are going to be negative and positive. So first step is switch them. So 7, 3, we get a negative because it's going to be in quadrant 1. I switch them, so we get 6, 7. Again, that's a negative in front because we're going to be in quadrant 2. Like 2, 8. Okay, negative in front of 2 because we're going to be in quadrant 2. And then 3, 4, negative in front of the 3 because we're going to be in quadrant 2. So let's graph those. Negative 7, 3. G double prime, negative 6, 7 is H double prime. Negative 2, 8 is I double prime. And then negative 3, 4 is J double prime. Okay. So notice here how we've rotated. And so we translated over 4 up 10, and then we've rotated 90 degrees. Okay, each one of those has been rotated 90 degrees. Right? Yes. Okay, and that is the rotation.